Hello friends, good evening. Welcome to Eastern Academy. We are discussing about controller programming as a part of embedded system programming. Today is a session 7. In this session, we are going to discuss about DAC controller. It's a very interesting one. So let's get into the thing. What is a DAC? Okay, so as I always mention, we have multiple steps. In first step in embedded programming, the first step is GPIO. The second step is controller, direct. Then third step is, that's actually direct means memory map. And third one is controller programming with interface, with SPI, I2C, everything. And fourth phase is controller programming using functions. So you have to divide them into the multiple steps. Okay. Understand? So first you have to cover this. In this GPA only we discuss about LED, 7-segment, switch, keypad, dot matrix. If you do this exercise, you will get a good idea. Okay. You will get a good idea. If you do these 5 components, they'll be very good. Lot of people are doing now. Slowly, a lot of people started moving to the 7-segment and the keypad. Now they start doing a dot matrix. They're doing quite good. So then controllers. We discussed about a lot of controllers, LCD, timer, everything. On that, we are discussing about DAC. Then next session we'll discuss about ADC. Then next class we'll discuss about motor controllers. Then we will discuss about this SPI, I2C, everything. Don't try to accumulate knowledge, please. Let me be very clear. Don't try to accumulate knowledge and a lot of terminologies. Nothing will help you. Terminologies will never help you. You can cheat somebody by telling as if you know everything. Oh, I know dot matrix. I know 7-segment, but no use. If they ask you to write a program, you should be able to do it. You should be able to show people, this is the program I have written from scratch. Can you believe it? You can write it on a online one and show the link to the customer employee. I have done this project. This is a link. You can go and check my thing. You can ask me any code. Today that is possible. Understand? When you give a resume, you attach your online link. These are the programs, I have done it. Am I right? You don't tell them that I know it. Show them what I have told. That's why I'm telling you that don't try to bypass. So now in the controller, in the embedded controller programming, we are going to discuss about DAC. What is DAC? It's a very tricky. All about electronics initial days was all about analog and analog. You'll be very surprised. In a transistor, when we are discussing cutoff, active and saturation, These two regions seems to be useless. That's the way they will tell you in the colleges. Saturation is waste and cutoff is waste. The actual good region is active region. Because transistor will amplify that region. Okay. Now the problem is you need to understand about analog first. Before we get into the DAC and ADC, we have to discuss a little bit about analog. Why we move to digital? Why? What is the advantage of analog and digital? That has to be understood before we have to have two things. So there are two things. One is called analog. One is called digital. The advantage of analog is I have a wire. I can transmit any voltage. If I apply 3.5 volts, it will go 3.5 volts. If I give 2.7 volt, it will go 2.7 volt. If I give 1.8 volt, that will take 1.8 volt. So, for example, I'm transmitting now 1.8753 volts. That it will be 1.8753 volts. So whatever I'm transmitting, I can go there. So understand? So that could be from 0 volt to, let's say, 5 volt. There could be infinity level. Any level you say, it is possible. That's why it's called analog, contiguous. It is continuous, all the things. But in digital, it's quite simple. I have only two levels, 0 or 1. 0 or 1. Okay, so if I give here 0 volt up to 2 volt, assuming, then that is considered to be 0. If I have 3 volt and up to 5 volt, considered to be 1. Only two levels. So what the receiver assume, if he gets 4 volt, he will assume it that's a 5 volt. Understand? He will make a correction. If he receives 3 volt, he assumes it to be 5 volt. So if I have one wire, I can transmit 0 or 1. Understand? Whereas in analog, if I have a wire, I can transmit infinity number of levels, 0 volt to 5 volt, any volt. Here I can transmit only two levels, 0 volt and 5 volt. So please understand here. So I can possibility with one wire, I can only two informations, either 0 or 1. Here I can transmit infinite information. That is the advantage of analog. But the drawback is based on the length. Based on the length and based on the material, based on the thickness, then the analog will lose the voltage. If I send 2.5 volt, this guy may be receiving 2.45 volt. But you don't know. The problem is you don't know. That depends on the wire. So if I have to transmit here 2.5 volt, I transmit 2.5, that guy have to receive 2.5. Then we have so many mechanisms. I'll be taking the wire here. I do the feedback, then take this wire feedback and then give a voltage. So this will be, I'll send it 2.7 volt. Then I know that it will go to 2.5. So these are all done by the feedback mechanism. It's quite complex. You know that open loop control system, closed loop control system, all of that. So people have one drawback with the digital is I transmit less number of signals. But one advantage is any voltage between 3 volt to 5 volt, it's considered to be 5 volt. Suppose I transmit from here 5 volts. If this guy receives 4 volt, still that guy considered to be this is a 5 volt. Because 1 and 0, only two levels. So the advantage of digital is integrity. So what people did, they add two wires. They add how many wires? Two wires. So I can transmit 0, 0, 0, 1, 1, 0, 1, 1. I transmit 4 numbers. Then if I add one more wire, 3 wire, I can add 2 power 3. I can send 8 information 0 to 7. If I have 8 wires, 8 wires, 0 to 7. 8, I have 2 power 8, 256 numbers. What they did was this. They had made a controller. You give here 8 levels, 8 wires, 0 to 7. I'll explain to you how it works. I have only one output. I apply here 5 volt on ground. And I apply a voltage called reference, 5 volt. What is the reference voltage is? When these numbers are at peak, they use it. It's having 8 wires. So 2 power 8, 256 levels. So 5 volt divided by 256 levels. So every number here from 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0. Then up to, say, start with 0, 0, 0. 1, 1, 1, 1. The problem is, you have how many levels now? 1, 2, 255. You have 255 gaps because 0. Let us say 0, 1, 2, 3. How many numbers? 4 numbers. How many gaps? 3 gaps only. So if I divide by 4, if for example, take this one. I take only the, I'll give you a small idea now. Now the thing is that I have 2 wires and I have one output. Assuming now I apply reference voltage as a 5 volt. Now that guy will divide into 2 wires. 2 power 2 is 4 levels. Understand? Correct. I'll come to the point next. Now 2 power 2. So 5 volt divided by 4. So what is the thing is 1.25. I mean, it's a 1.25 level. So what they do here, thing is, they will have every number, there is a voltage. Every number 0001 means 5 by 256. 0000, sorry, 10 means 5 by 256 into 2 because number 2. 000000, 11 means 3. So 5 by 256. So if you give me any number, I will tell you the voltage outside. If I give 11111, what is the voltage? 255 divided by 256 multiplied by 5 volt. You don't get the exact 5 volt. If I give all 1, I get only 255. Understand? So let us come to the point now. How this works. So that means that if I give this box, if I give any input here, I will get a analog output. Why we need analog? Because your lot of components, your real natural world is analog. For example, your sound, your voice, music, all of them are analog. They are not digital. If you put the switch on and off, you don't hear. Here, let us say I have a speaker. Here there is a sound. So the sound will come. Understand? Now, I store a file. Let me tell you the small application before I get to it. I'll explain to you how the DAC works. I have a hard disk. I have a music file. I have a music file. Then I have a microprocessor. I have a memory. Then I have a DAC. See, this is a combination. See that? I have a hard disk where my file is there, music file, maybe ESN 1.mp3. Have a file. Then I have a microprocessor. I have a memory. Now what happened? When you run your application, that game will read this file and put it onto the memory. So now the file comes here. These are all numbers. These are all numbers. Then there is one more controller is called timer. There's one more controller called timer. What the timer will do, at regular interval, it will give the interrupt. I'll explain to you why. I'll explain to you why. That's very important. You should know now. At regular interval, it will give you the interrupt. Maybe let us assume that it is giving the interrupt on every 125 microsecond. I'll tell you why. Why I chosen a 125 microsecond, I'll tell you the reason. So every 125 microseconds, this microprocessor will get the interrupt on the ISR, interrupt service routine. It will take the number from the array memory and send it to the DAC. So DAC will convert it, then it will come to the speaker out. So the DAC, based on the number, you will get a small voltage. You will get a small voltage. Then after 125 nanoseconds, I will go and read the second number. Then I will send you DAC. That time DAC will put the other one. After 125 nanoseconds, see, find out why I'm telling you. See how the timer is used, how the memory is used, how the hard disk, actually it's not hard disk. I did a small mistake here. Hard disk controller and to the hard disk. All these things are used by your mobile phone. Understand? When you try to play a song from your disk, SD card or your flash memory, everything. Your computer hard disk, this thing. Now, so the timer is going to give you interrupt every 125 microsecond. The ISR will be called that time. He will go and read the number and set it out and increment the pointer and go back. So every 125, I'll get some data. I'll get another data. I'll get some data. So finally, if you see, this will be a waveform. That will be your voice or music. You understand now? So now I have to tell you two things. One is why I have chosen 125 microseconds, which I have to explain to you that. Second, how the DAC functions. We have already discussed about timer. We know that. Every 125 is thing. We have not discussed about hard disk controller. Now forget it. Leave it there. The speaker, you know that whatever voltage you give it, it's going to do that. Sound is a magnetic one. When I start giving this, it's going to do that outside. Okay. This is what exactly happening on your when you try to play a song. Now I'll explain to you that how the DAC works. Let me put a very simple thing. We know that I repeatedly told you so many times. Please give more importance to the voltage divider in electrical. How it is getting used now. Let us see that. I have two resistors. I have two resistors. If you apply 5 volt here, Okay. What is the output? Let's say this is okay. Some resistor R and R. What is the voltage you get? 2.5 voltage. Am I right? Now, if I give here 0 volt, I get here 0 volt. If I give here 5 volt, I get here 2.5 volt. You understand now? I'm getting 2.5 or 0 volt. So 0 means 0 volt, 1 means 2.5 or 1 means 5 volt. This is what you are applying. Let us assume this is a box. You apply from outside 0. Have this a box. And you apply 0 volt means you get 0. You apply 5 volt means you get 2.5. This is you are converting 1 bit. Now let us try to take a 2 bit. You'll slowly understand now when you try to take 2 bit. So now tell me what will happen. If I apply both of them 0 volt, what is the output here? If you apply both of them 0 volt, what is the output here? So this is 0, this is 0. So this is going to be 0. Okay, this is going to be 0. Now I can draw like this one. 0. You get here 0 volt. Understand now how I get a 0 volt now? You get 0 volt. Fine. That's correct. A lot of people said 0 volt. Now think of it. I make this one as a 5 volt. What happens now? This is R. I make this one as a 5 volt. And this is 0 volt. And this is R. No, no. I'm not asking here. I'm asking here. Here you get 2.5 volt. That's correct. The divide. But what is happening is when I take this guy like this and I put 2.5 volt and this is 2.5, this is 0 volt. This is R and 2R. So what do you get now? No, not 0 volt. Not 0 volt because this is 0 volt, this is 2.5 volt. There's a potential difference. So 2.5 divided by 3R and into 1R is a voltage. So you get 2.5 by 3. Understand? You get about some 0.83 volts. Understand that? You get about 0.83 volts. If I apply 0 and 1 here, please, I'm requesting always to you, never forget the voltage divider. Yeah, 2.53R. That's correct. Now, I have the same resistance here. I make this one as 0 volt. And I make this as a 5 volt. When I make both 0, see, when I make both 0, 0, I got 0 volt. When I make 0, 1, I got 0.83 volt. When I make 1, 0, what do you get? Now what happened? This gets 0 volt. This is R. This is 5 volt. And this is 0 volt. So what happened? When it's like this. R. And this is how much volt? 0 volt. And 5 volt divided by how much? Five volt. This is 2R. This is R. So what voltage I get here? Five by three. You get 5 by 3. This is 5 volt, this is 0 volt. This is 2R and R. 5 by 3 is equal to 1.66. You get how many voltage? 1.66. Now, see, try to go back and do the thing at home. Okay, I cannot, I'm just giving you the idea now. I'm just giving you the idea. If you give both 5 volt, then what happened now? This is 5 volt, this is 0 volt. This become 2.5 volt. So I make this guy like this. And this is 5 volt, this is 2.5 volt. Then what is the voltage here? Can you guess it? This is R. And this is 2R. What is the voltage here? We need to do that. That's why I'm telling you that you are moving away electrical very simple. No, man. No, you are not correct. What is the voltage here? Can anybody tell me now? I've repeatedly told you that don't underestimate Ohm's law and power law. Very simple two equation. V is equal to IR and P is equal to VI. No. Let me wait. Let me take one time. Let us see that who is doing the right answers. And this one is 5 volt. This one is 5 volt. And this one is 2R. This is R. And this is 2.5 volt. What is V naught? Anybody? I want an answer from you. I'm ready to wait. I'm ready to wait. I want an answer from you. Please. Anybody, please. Take your own time and give an answer for me. Now you understand where we do the mistake. See, just 1 minute. There are two people. This guy is having 100 rupees. This guy is having 500 rupees. This guy is in between. Can you tell him this guy have 1,000 rupees? This guy will be more than 100, less than 500. Because this guy is in between 5 volt and 2.5 volt. So this guy have to be less than 5 volt and more than, because current will flow like this. So this guy will be in between 5 and 2.5. I want to know that what is the voltage here. No. No. So far, I have not got the right answer from anybody. So you all have to go and refresh Ohm's law. See, now you understand. Now you understand. It has to be more than 2.5. It cannot be less than, because this is here in between 2.5 and 5 volt. This guy has to be always more than 2.5, less than 5 volt. So he cannot be more than 5 volts and less than 2.5 volt. We have never understood voltage properly. We never understood voltage still. You have to watch the electrical videos once again. Please, somebody. I'm still waiting. It will take some time. No problem. Because if you don't understand this, you will never understand anything. Afterwards, whatever I'm discussing. I am trying to tell you much easier way. Actually, this has to be explained through the Thevenin's theorem, which I don't know. I don't want to get into the Thevenin's theorem, and then you will get more confused. I am trying to put it in a very simple form. See, I'm trying to solve it in a very simple. The question is very simple. See here. The question is very simple. That I have two resistors. And I have resistor. If I apply 5 volt, this is R and R. I get here 2.5 volt. 2.5 volt. Now what I have done, I have removed this and then removed this. And this is 2.5 volt. So I drawn like this. This is 5 volt. Now this is 2R. This is R. Now my question is, what is the voltage here? Please. Anybody? I'll wait for another 2 minutes. No problem. I can wait, but I want to answer. Yeah, no. It will work. If you give a voltage, there'll be a ground automatically is there. Only with the ground, I'm giving you the diagram. Please understand, it's a very, very simple problem. Somebody have got an answer for much closer, but it's not correct. Let us see that. See here. What is the potential difference? 5, 2.5. So the potential difference is 2.5 volt. 5 minus, because difference is 2.5 volt. Now, what is this voltage? V1 and V2. This is 2R. So this guy is 2.5 divided by 3R, because 2R plus R is 3R into R. So RR. So 2.5 by 3. How much? 0.833 volt. Am I right? This guy is 2R. So multiply by 2R. R cancel 2 by 3. That is equal to 1.66 volts. Understand? Now, here is you people have got this. Your problem is what is V0? V0 is equal to 2.5 plus V2. V2 is a potential difference plus this between 2 points. So V2 is equal to V0 minus 2.5 volt. Do you agree that voltage is potential difference between these 2 points? So what we get was how much? Now at least 2.5 plus 0.833. 2.5 plus you get about 3.3 volts. So get here 3.3 volts. So it's like this. 1 0 means I get 1.66 volt. 1 1 means I get 3.33 volts. That's all possible. There are 4 combinations here. For every voltage, I get a different voltage. So this, now the same thing they will do. What they will do here is, I connect now I added one more. Now I get 3 levels, D0, D1, D2. If you analyze, you will get here 8 voltage levels. So these resistors are 2R. And these resistors are R. Only this one is 2R. So if you see that, this is called R, 2R ladder network. Okay. I'm not here to explain to you, because if you're interested, you see that I can share some videos. It's available on the YouTube. And this is not I'm trying to explain to you that how they convert a digital signal into the analog by using a resistor alone. By using a resistor of value R, 2R. D0 to D7. It goes like this, all of them. The output goes here. So this is called actually DAC. Digital to analog converter is a simple one. Do you understand this? You could have studied in the college everywhere. When we try to make analog to digital everything, let us say I speak. This is my voice. I'm speaking to you, there's a voice. Now, there is a block called ADC. That's called, we will discuss next session. The ADC will take the signal here, analog signal, and give you digital signal. And here, I have a timer that guy will do it every 125 microsecond. I'll explain to you that why I'm taking the. Yeah, all squares are rectangles. If we say that 0 volt and 5 volt only, then digital. 0 volt to 5 volt, then it is analog. So in analog, 0 volt also is there, 5 volt also is there. But you have in between all the voltage. 0 volt to 5 volt is called analog. 0 volt and 5 volt only, then it's called digital. So understand the difference. If I have only, then that is digital. The 0 volt to 5 volt. So you cannot say that the voltage is analog or digital. All the voltages are analog. But if all sides are equal, then you call square. Otherwise, it's rectangle. Am I right? If opposite sides are equal, then that is rectangle. The same way here. So please understand here, 0 volt and 5 volt only means digital. 0 volt to 5 volt, anything is called analog. Now I have a ADC converter. What the ADC converter does, every 125 microsecond, he will convert this voice. But so if I speak continuously, whatever the voltage here now, I will take the next two voltage after 1.125 microsecond. In between, all the voltages are gone. I take only the two voltages. Then I will take after 125 microseconds. So what is happening? This is what you have to understand. These are the things we normally get. In the college, you study something called signals and systems. This is actually called analog signal processing. That is, for example, I give a voltage, I put a capacitor and resistor, I get out. This is called analog signal processing. You know, this is what filter it is. This is a high pass filter. If you want to know that how it is high pass filter, then watch our analog electronics videos. That I expect you that how is it. Now, in this case, what we do here is we give an analog input and the circuit is using transistors, everything, and we get analog output. But nowadays, what we are doing is we take the, let us understand here. One simple thing I'll tell you. I have a mic. I have a mic. We take the data from the mic. For mic. Now, what we do here is we will convert this. What mic does is a converter from sound to electrical. It is converting a sound to electrical. That is what who does? Your mic does. This guy is called ADC. What is a ADC does? He converts electrical to number. Now you understand. It goes to number. Then these numbers are taken by your microcontroller. Then the microcontroller will give these numbers out. And I have somebody called DAC who will give this once again electrical signal. And this is number. So this is number to electrical, opposite to this. Then here I have a speaker. Gives you sound. Back. This is called, what you are doing here is called digital signal processing. Or this is called famous DSP. That's why today, your phone, everywhere you heard something called echo cancelling and all. And you do the speech in a Google Talk or somebody understand for Siri and all. Your Alexa understand your voice. How come they understand your voice? That is because of this DSP. That's one of the beautiful field. But this is 100% mathematics. If anybody is interested in mathematics, do this. It's a wonderful field. So there are two components here. One is called ADC. One is called DAC. What I'm going to tell you is very important thing. That is what the trick. As we discussed here, when the sound comes here, there's a sound wave. This is a sound wave. The sound wave is getting converted to electrical wave like this. That guy does not change. Please understand, the sound wave is getting converted to electrical wave. Now, when it comes here, as I told you that this guy will do it every 125 microsecond. So every 125 microseconds, I take this number. In between, I lose. So what happened? I get only 4 numbers of this. See here, I get only 4 instances. That means that you speak like this. I will take only the 4 values. This is called discrete. This is called continuous. Understand? This is called discrete. Now, that is what this is called sampling. That means that I wanted to tell you that whole principle. Then I thought I will introduce the word called sampling. You know, somebody has already said sampling word. This is called sampling. That means I take, now I come back now. The thing is like this. My speech is like this, waveform. But I take only how many samples? 4. 1, 2, 3, 4 samples. There are 4 numbers. Let us assume this is 0, 0. This is 255. Or 0 volt or 5 volt. Number means this. This is a voltage. Whatever you can represent. That's what I said. When analog ADC inside is a voltage. Outside is a number. Now, you'll be thinking that, hey, if I give this to the speaker, will I get this? I say hello. Will I get hello? Or you may think that how many samples I have to take such a way that my voice to become very clear. Please understand one thing. My voice is this. Do I have to take 10 samples or do I have to take, but there's a problem. If I take 10 samples, that means 10 numbers. I have to store so many numbers. I'll explain to you that on those things, everything, I'll explain to you now. You will thoroughly understand about audio, please. I'm not interested to go hurry and fast. I'm trying to explain to you that what is. That time, there is somebody. You know what is his name? Do you know what is his name? Most of you know that. His name. Anybody knows his name? Nyquist. Very good. Somebody has called Nyquist. It's a perfect. You at least remember. Thanks. There's a scientist called Nyquist who finally did a lot of research. You know what he came out? It's a very surprising he came out. He did a very surprising thing. That is, if your waveform is like this, if your speech, if your voice is like this, if you take 2 samples, how many? Only 2. Then you can able to construct a voice. That is what Nyquist has proved it. That is called sampling theorem. That means that if my waveform is this, I'll be able to take 2 samples enough. That means 2 numbers. Understand, these are all not sample. Every sample is a number. 2 bytes. But now I'll come to the very important point. What is the frequency of the human voice? Can anybody tell me? What is the frequency of the human voice? Don't get confused with audible. Audible voice and audible signal and voice. What is the frequency of our human voice? Can anybody? Oh, that is 20 to 2000 is this audible. You can hear 20 hertz to 20,000 hertz. That is your hearing capacity. What is the frequency of your human voice? What is the frequency of the human voice? Can you guess? Oh God, it's a very surprise, man. Nobody knows the human voice frequency. We have studied electronics in the college. It's a very important numbers. That is actually 3 kilohertz. How much? 3 kilohertz. People thought, let us assume the worst case. Somebody is having a high pitch voice. Let us assume that guy is having 4 kilohertz. So scientists have assumed 4 kilohertz. Actually, 3 is the correct number. But this is approximately 3. Not each and everybody's voice will vary around 3. But they have given a small tolerance such that you can able to do the other one. That is 1 kilohertz. That somebody is having a high pitch voice. What are you doing? Like that. Then the frequency will become increased. When somebody says, what are you doing? Then that frequency will be less. Okay. When you put a very violin and a very high tune thing, that is why this 20 to 20 hertz is music included, not voice. Don't get confused between the music and voice. Okay. So we do that. That's the way your voice is generating the thing. See, this is very important. You should know, man, because today I have done the full microprocessor course. You know that I have done an animated course of microprocessor. The entire thing is computer generated voice. I never spoken a single word. I take everything on notepad and gave it to the software. The software spoke all the voice. I'm creating another animation like that. All my animations are going to be, one advantage is that is, I create only one text. Now I can make it as American English or Indian English or Australian English or British English. I don't waste my time. Please understand that. So do you accept this? So what people did was they accept that voice is 4 kilohertz. 4 kilohertz means like this. What is 4K kilohertz? That you have to understand. That's called frequency. That means that like this, there are 4,000 cycles per second. 4,000 cycles per second. In 1 second, I take how many cycles? 4,000 cycles. As per the Nyquist scientist, we have to honor him. Because of him only we are speaking everything. The Nyquist said, you need to take 2 samples. That means 2 numbers per cycle. Please understand what Nyquist said. 2 numbers, 2 sample, or 2 numbers per second cycle. 2 numbers per cycle. Now you have how many cycle? 4,000 cycle per second. So 2 numbers per cycle. I have 4,000 cycles per second. So totally I get 8,000 numbers. So if I speak now, understand now. Now I'll come to the point now. This number is very important. If I do the speech, if I take the samples, your voice is sampled at how many times? 8,000 numbers per second. That means that between numbers, what is the duration? 1 by 8,000. That is equal to 125 microseconds. How we got it? 1 by 8,000 is equal to 1,000 by 8,000 millisecond, because I added 1,000. So you add these things. That is equal to 1 by 8 millisecond is equal to 1,000 microsecond divided by 8. 1,000 by 8 is 125. Now you understand how I got the number. These are all you will study in the coming college. You will study or maybe study. That time you remember the number 125 microseconds. So what we do here is, this is a beauty. This is a beauty here. Correct. Perfect. Every system is having ADC and DAC. Now, from here, there's a timer. This timer will sample it every 125 microseconds. Then it will store the data in the hard disk. This guy is having a RAM. From RAM, it will store to hard disk. Done. That means that I store your voice. This is called recording. So if you speak for 1 minute, if you speak for 1 minute, then 60 seconds into 8K, that means 480 kilobytes. For how many seconds? For 1 minute. For 1 minute, you have to save about 480 kilobytes. Do you understand how big number this is? This is only, I'm talking about audio. When you come to video, we'll discuss later. That time you'll be very surprised. I don't mind to talk everything, but only thing is how much time you will have it to listen to all these things. I work fully on these audios, videos, everything. Correct. Somebody has given very, very clear. But the problem is, if you take more than 2 samples, let us say, if you take 4 samples, then my 8K becomes 16K. So that means that for 1 minute, I'll get 9,600 kilobytes of storage for 1 minute. If you take more sample, it will be more. You go and check this one, all the audible and everything. Audacity, you know that you go and download the software. Audacity. It's a good audio recording software. There you can go and see all the samplings and everything. Audacity. It's an open source software. See, try to give lots of importance to learn these things. It's all very interesting, but they will give you the beautiful opening in every company. Don't always go away, shy away from the technical things. This is all very interesting one. And I told you I'm there. Whenever you have a doubt, you can come to me. Now, the beauty is, for 1 minute, I'm taking a mic. I say that, hello, how are you? Welcome to Eastern Academy. I speak. My mic records this in the hard disk as 480K. Done. Recording is done. I send the file to you. Then what you will do, you will play back. That time, from this number, when you are sending it back, you have to send it same time. If you don't do it at the same time, I sample at 125 microsecond and you should play back at 125 microsecond. Otherwise, I speak here, welcome to Eastern Academy. Here, if you put instead of 125 microsecond, 100 microseconds. When I speak, welcome to Eason Academy. When I goes here, it'll become welcome to Eason. That's all, you're gone. My voice will not be the same here. So the sampling have to be same. That is why on the file, the header, they will save the sampling thing. Correct. Yes, you are perfectly right. There is 125 microsecond. Okay, they sample and send it. This is all exactly you are right. Now you start understanding about, you will be here about voice over LTE. Am I right? These are all very simple. What I do here is I take my voice to digital and send it over the LTE. That's what 4G. You start understanding everything. These are all the technology which I'm explaining to you is all very fundamentals, which you don't get it. The problem is you will get all these things broken pieces. You don't get the whole piece in the YouTube. That is what I'm explaining to you now. Yeah, you can increase the playback speed also sometime. Okay, that time also yeah. The problem is, if you increase the playback speed and if it's still you are getting it clear, it means that technology is fairly okay. Okay. That's why normally you have a YouTube and you do sometime Udemy and all. You can change the playback speed. But actually, to be frank, both has to be same. Okay, now I'll explain to you how the ADC work in the next session. How ADC works. Now we have no ADC. No, it is fixed. 125 microsecond, please, not millisecond. 125 microsecond, don't mistake it. In any interview, anywhere you say 125 millisecond, they will laugh. They don't understand. They will say it's a mistake. 125 milliseconds means 8 hertz. 125 microsecond means 8 kilohertz. Please understand. Never do 120. This is not 125 millisecond. Everybody is using standard 125 microsecond. That's a standard. I'll explain to you that the multiple standards are there. PCM, MP3 and all. I'll explain to you that what is MP3. How they don't store it on the 480K now. Nowadays, if you say 1 minute, they may save it about 5 to 6K. This guy is called sampling as such. This guy is called compression. I'll explain to you the next session. How do they do the compression? Voltage will not change. There's nothing to do with the voltage. The voltage will not change. The voltage is same. You give the number, that guy is going to give the voltage. The number is same, but you give it the wrong time. So what happened? Let us assume that. Let us assume that I speak here. You take my voice here and at here. Wait, this is at 125 microsecond. And if you give it at wrong time, then that guy will take this as the peak time will be of this and the other peak will be this. So what happened? That guy will construct a voice totally different. The waveform will be totally different. Not the same waveform. If you don't maintain the time. So the sampling is a very, very important terminology. So let me keep this as such. So walk through them during the break time. I'll take a break now. Then you can reduce. Yeah, people. I'll explain to you in the next session. People are reducing that less than 425 milliseconds. I'll tell you when we do that. We do that. Then I'll explain to you that thing. Very good. Yeah. Somebody has asked why I have to reduce. That's very good. See, I always welcome this type of questions. You need to ask this type of questions. I have an answer. If I don't know it, I'll say I don't know. If I know, I'll share with that. Since fortunately, if you don't, once again, you are doing a mistake. It is not 125 millisecond, 125 microsecond. Please understand. Never write it. People always have the habit of writing 125 millisecond. That will put you wrong thing. 125 micro. There's a big difference between 125 microsecond and 125 milliseconds.